All right. Right, so we lie there, nice. We good. All right, so let's take a couple modeling questions, right? Let's try this first one. I'll call it out, right? Right, in mass and grams, let's write it now. We're going straight into questions one time. The mass in grams of a piece of radioactive material, the mass in grams of a piece of radioactive material at time t years, right? So the first thing we see in mass in grams, time in years, right? Mass in grams, time in years. Is modeled by the following formula. Is modeled by the following formula. M is equal to 6e to the minus 0.12 t. Okay, so we have this model equation here. Right, this is a model equation. This is used to model how mass changes with time. Okay, that's it. How mass changes with time over years, over a few years, right? Okay, so I wanted to understand what it asks, right? All right, so first part, the present mass of a radioactive material. So the first part is they want to get the present mass. What is the mass at this point in time? What do you do? Who got the formula? What I mean? Huh? What would you do? Find for T to get the present mass. You want to find for M. Want to find for M, right? So this physics of pure is pure, Rihanna. Remember, we just finished exponents and ln and thing. Right. Samara said, no, we don't apply log and bring it. They want the present mass, the initial mass, sorry. The initial mass would have been a better word. Right? They want the initial mass. So they want the mass when T is 0. Right? So they want the mass when T is 0. So that'll be 6e minus 0.1 T to the 0. This is 0. E to the power 0 is 1. So the answer is 6. But in what? Gram. So the initial or the present mass is 6 grams. Okay? That's all we need. That's all. Right? Second part, part B. Part B, the mass present after 5 years. The mass present after the mass present after 5 years. Find out if somebody else.
Easy. Explain this.
Yes. Right, so find the mass after 5 years. Right, so all we're doing, we'll be using the modeling equation. M is equal to 6e to the minus 0.12. Time is in years, so you put 5. And that'll be something graph. How much?
I guess 6 equal to 0.6 grams.
How much?
6 equal to minus 0.6.
6 to the minus
0.6.
So you didn't work it out?
Yeah, well, 1.12.
Right. So much you get in the end?
50.
20 calculator.
You answer.
Oh, you'll never use exponent in the calculator? Just look for e. 6 multiplied by e to the minus 0.6. See e? Right, and I have power on top.
Yeah.
Amanda got 3.29. Amanda got 3.29. We now started here.
Yeah.
Adrian, we now started. Adrian, right? Yeah, we now start this modeling. So we're using exponent function to model a function. Are you okay with that? Yeah. So when you use exponent, you're getting 3.29, right? So again, everything really comes from here. How do you do part 3 though? Time for the mass to reach half of the original value. To reach half of the original value. What do you do there? Time to reach half of the original value. What are you gonna do? Well, kind of, yeah. So now the mass is what? What's the mass? 3. So the mass is 3. The formula is 6e to the minus 0.12 t. Half. Half of the original. Half of the original. I didn't write it here because I didn't want to go on this side. Right, yeah. Where are the solve for now? Solve for t, right? How are you going to solve for t? Really? Go ahead, have fun. Do that part. So solve this. What the first step you're doing, Shavish? What the first thing you're gonna do? Well, what you gotta do is take ln on both sides. Right? You can bring the 6 across if you want. You can bring the 6 across. And then when you reach here, what to do? Take ln on both sides. Because you have e here, right? So take ln on both sides. Ln here is equal to ln here. What is ln e? Ln E is 1, right? So you'll end up with ln of 0.5, whatever that is. Ln E will kind of cancel, you could say. So you will get minus 0.12 t. And then make t the subject. T is equal to minus 0.12 over ln 0.5. That's all. That is all. That is all. You like to call when it's outside, right? Okay. Anybody get value? 0 point? Yeah, you can bring the power rule there and then find ln E is 1, right? So technically, that's what I did. I took the power, bring it in front, to bring it down, and ln E is 1. Or you can see ln E of anything is anything. So ln E of 5 is 5, ln E of 3 is 3. So ln E of this is this. Right? That's technically what I did. How much y'all got there online? Once again?
0.173.
0.173 yes? Why that's something wrong? I took 5 years to reach 3.29. Oh, I have it back to front. Oh, see that? I put this here. I put it upside down. Who said that? Who should we? Oh, you. I thought should we say that? You want to know? Yeah, sorry. I wrote it the wrong way. I thought should we say you want to know? I'm doing some kind of videos there. So they have topic video like to do that. Shorter tricks. Trick already?
Yeah.
Yeah,
Huh? Sorry. Trick already?
We don't drink. No, we start 1 2.
Okay, then you got
yeah.
Original one like that, but that'll come like that.
right 5.8 years. All right. Try one more like this one, just to get familiar with working with ln. Right? Find the time to reach. Time to reach 2 grams. Time to reach 2 grams. Right? How much you got? So you want the time to reach 2, right? So 2 is equal to 6 by e to the minus 0.12 t. carry across this and take ln, so you'll get ln 216 is equal to ln E 0.12t. Ln you cancel, you'll get ln 216 is minus 0.12t, and you can easily solve for t. T is equal to ln 216 all over minus 0.12. 9.2, right? That will do. 9.2 years.
We take 5 years. To reach 3 months.
5 years to reach here, 5.8 years to reach here, 9.2. It's exponential, so it's not straight line. Right? It's exponential. Nice. Let's go again. Let's go again. Find these two here. I change the function on here. Find the present mass. Find the mass after 5 years. Right? And find the time taken to, I'll tell you this now. So when you see modeling, this is what I'm talking about, right? So otherwise you'll be surprised to see one.
250.
Yeah, 250 by half to the power 2. Let's try next one, right? Ready? Kind of treat it as Right, what we got? We get, what we get? We close strong, you get. Huh? Second, we have 1.6 years. Right, so this is the modeling question. Present mass means when T is zero. So you're plugging in T is zero here. 250 by a half to the power zero. And into the zero is one, so the answer is 250 grams. MIT too. MIT. No, right. M in terms of T. All this means that in terms of T. Sorry. No, that is like M of X. It means M of T. Column multiply M of T. Alright, sorry. Fix it, please. Online, in case you do that, fix it, please. Right? If you see this, M of T, it simply means the function M is in terms of T. Yeah, I get like we were like Anthony Power, it's so we learn to be
Online, what I give us the answer. Please.
Yeah.
Right, here's what now? 250 by a half to the power of 5. How much you got here?
7.8.
7.8. Right, now, time for the mass to reach 125. Here's 125. Here is 250. By a half to the power of t. Alright, because 250 here,
Yeah.
you will get 125 on 250. It's a half t. So a half is equal to a half to the t. So t is how much? 1. T is 1. But let's just say what the worst number. What would have done? Take logs on both sides. There we go. Right? So of course we could see it here that t is 1. Right? Anybody got that online? T is 1?
Yeah.
Oh yeah, no. Look. Let's do again. All right. So that's technically what your modeling will look like. All right. I'm gonna give you one last one, and then we can take a look at. Then we can take a look at transformation. I gave you E, I gave you T. Gave you that already. I gave you that. Huh? Transformation in function. Right, so I'll give you B and T. T is in years. T is in years. And V is the value in thousands, right? Value in thousand. Right, so the equation I'm going to give you is VT. Huh? All right, because that's what you're going to see in exams. Oh, why are giving it, right? Now, this came already. Right. 365. Part 1, I would like the initial value. Right? You can take it now. Right? Check. Try to get your original value. And the time. Yeah. So find the time to reach $91.25 thousand, right? Yeah, the value $1,000. Dollars. Sorry. What kind of equation is that? Compound depreciation. No? The compound depreciation. Now you're going down in value, right? Because of the minus, right? So what you put T to be here? Initial value. T will be 0. So put T is 0 and work it out. But remember your value in thousands, right? And here's the other way around. You had to solve with T. Take long, right? So that's past method the answer.
And 9.2. 9.2.
All right, so when T is 0, right? When T is 0, you'll get V of 0 to be 365 by e to the minus 1.5 by 0. And to the power 0 is 1. So you'll get 365,000, right? Here. Up here. Time to reach this value, so you put in 91.25 e to the, sorry. So you're going to put 91.25, right, is equal to 365 by e to the minus 0.15 t. Carry this here. You'll get 91.25 over 365 as e to the minus 0.15 t. All right. How much is this?
Minus 1.2.
This is what?
So we take a lot.
So you take ln one time, but it's a quarter. So this is ln of a quarter is equal to ln e minus 0.15 t. Ln e now cancel, so you'll get ln of a quarter all over minus 0.15. Years? 9.2 years? Yeah? 9.2 years? All right. Nice. So that's the end of that modeling thing. I wanted to show you how, if that ever comes, how to handle it, right? There's the next modeling in differentiation. All right, next heading, transformation. Sorry, functions, then subheading, transformation. Right, so I want you to head up for functions. Function. Let's take a look at function. Right. Any questions online? And last thing?
Yeah, that's right.
Huh?
Yeah, that's right. Yeah.
Nobody going now. I'm going so fast. All right, so there are 4 standard graphs that we need to know. All right, these are the 4 standard graphs that we should know. Of course, we'll have the A to the X graph, actually, let me add that in to us. Right, so these are some graphs that we should know. And then all the other graphs that we're going to sketch kind of come from these graphs here. All right, so let's see if we can sketch them. Y equals to X. How does that look? Straight line, right? To the origin, right? Y equals to X, straight to the origin. Y equals to X squared. How does that look? Not starting from the origin. Y equals to X squared looks like this. Wherever so the okay, find that TikTok graph. There's somewhere off the picture that show you all these little shapes. What does a cube look? Something like that. Something like a tan. You remember the tan? Something like a tan. 1 on X. We'll pay attention to that just now because this is the one that come the most. Right? And E to the X. What does this look like? Like if it is last 2 weeks. Yeah, like the exponent. Okay. This one here is one that we had to pay attention to. When X is more than 0, the graph belongs to this function here, to this side here. It has 2 asymptotes. You know what a asymptote? Right? The curve will come close to it, but never touch it, right? And when X is less than 0, the asymptote is here. The asymptote is the X-axis again. And the Y-axis. Right? Don't let it touch, right? Right? It's not touching here, yeah? Yeah, these are asymptotes. Right? All these here are your asymptotes. Right? There's an asymptote here. Okay, copy them down. And what we're going to learn to do is do some transformations on all of them. Right online? So draw these 5 and we're going to apply some transformations on them. Yeah. Yeah. Here, so we have to learn all, right? We have to learn all these curves. And now we're going to apply transformation to them so that we can draw them without having to memorize those, right? So transformations are things like this. Suppose I said y is equal to minus x squared. What you'll do?
We understand.
BD,
We the same thing.
y equals to minus x squared. How will that look?
We the same thing.
It'll be down,
Oh, yeah, we said, yeah.
right?
That's come out, yeah, well, it's-
Minus come afterwards, right? If I said x squared plus 2, what will that do?
let's get everything across the two.
Plus 2 means all the y values will add 2. All the y values will increase by 2. Right? So we're going to look at the transformation and what transformation will do to these graphs. So for example, if I ask you to draw y is equal to 3x squared minus 2x plus 2, this is a transformation of this. All right? A little more complicated, but this is a transformation of this. Okay? So let's take a look at all the transformation. Anybody join online? Anybody online join? No? Okay. So let's take a look at these transformations here. Hold on. Still working on this with a sum here, but this thing, right? Right. So first thing first, if you see f of ax, I want to write down all these summaries here, and I'm going to show you, how to use it, right? All these here are the transformations when section that we can use, right? The first one, f of ax, right, is a stretch along the x-axis by a factor of 1 on 8. Okay, stop them now. And we're going to do all of these. Yes, plenty.
You have the same thing?
Wow. Nah, I didn't get to this subject. So write it down. Write it, Timothy. I think you want to write. You should write it down.
But whole week got to there. I mean, every day.
Alright, so if you see A in front of the X, it's a stretch along the X axis by a factor of 1 on 8. Okay? If it's A in front of the F of X, it's a stretch along the Y axis. If you see F of X plus A, is a shift to the left by A units. If A positive is a shift to the right. Okay, push that thickness on.
Yeah. That's all right.
Very sharp. It's the right technology.
Dude, I have been more.
No, it's important.
On the other two, right?
I was put on the iPad. Okay, I know. Tight text.
That was Bihar.
Now, it was really good. Huh?
You know, I mean, like, that's what it that was the best one, like, that's it.
Good.
Yeah. We do that, for the first 6 hours, we were kind of adapt now.
Right, so when the A next to the X, you shift left or right. When the A outside of the function, you shift up or down. Okay? When the minus by the X, you reflect in the Y axis. Yeah? Hello? Huh? What?
Why not?
Right? F of X plus A, right? You shift up or down, minus F of X. Right? You reflect in the Y axis. Well, what about if the minus outside? Actually, yeah,
Yeah, I know.
what about if the minus outside the F? What you'll do? Reflect where? In the X axis, right? Okay. Right, so that's the last two. There's one more, but I'm not doing it as yet. When we do modulus, I'll show you that. All right, so actually the last one was modulus. But I'm not doing the last one today, right? Because I have to show you modulus first. Right, right this one, right this one. Alright, so let's go. I pick it up. TBC, I was stubborn. Once you can read it. Yeah. I know writing like that. You write it. Carry on. Alright. Alright, nice. So let's apply a few here. So the first transformation, we're just gonna focus on y is equal to x squared, right? So let's see if we can transform example 1. Let's see if we can transform y is equal to 5 minus x squared, right? We need to figure out the transformation to apply to x squared and then sketch it. If you look there, of course, you identify that the main function is this, right? So what are the transformations? I'm just going to write it like this before I apply the transformation, right? So if I write it like this, I'll see it firstly that I have a minus in front here. That's the first transformation. Then they add 5 on the end, right? So this first transformation says what? Reflection in the x. And this transformation says moving 5 up or down? Up. Right? So you're taking y is equal to x squared and you're reflecting it in the x-axis. Then you're moving it up 1, 2, 3, 4, 5. Right? So the final thing looks like this. So of course, stage 1 is here, right? Stage 1 is here, stage 2, then stage 3. So your function is here. Right? Well, that's why you have to learn. That's why you have to learn the transformation so you wouldn't get it wrong. No, that is perfect. Right? So you start here, you reflect in the x-axis, and then you move it up 5. Okay? So this is the first transformation, Timothy, and this is the second transformation. That's what the answer looks like. That's okay? Let's try our next one. Right, for you to do like vertical stretch and horizontal stretches be a little tricky to show, right? So you don't be able to identify it. Let's see if we can sketch this one here. X minus 2 squared plus 5, right? Again, you'll recognize that parent is this one, the one to start from. Okay, try this transformation here. Actually, let's do a minus this one. Try that transformation. What does it minus 2 here mean, Sharish? Huh? No, no, wrong. Look back at the rule. When the value inside the bracket. Look back at the rules. When it's x plus a or x minus a inside the bracket. What you guys do? Division on? Get it right now.
All right, don't put it.
Right now or
But I didn't write no more.
the second one?
So, it'll make sense that it'll make sense we expand it back.
Look it like this. So I was gonna give you one where you have to come back here. So what does the minus inside mean? It means the shifting to the right. What does -5 on the outside mean? The shifting down. So you're going to shift this 2 to the right and then 5 down, right? You can't just draw it randomly here. You have to put a point to represent the shift, right? So I have been shifting the point 0, 0. So in the first example, I shift the point 0, 0 to 0, 5. You have to show me what the shift would be here, right? What will be the point? So plug that point from it in your graph. So there should be this -2 means what? 2 to the. Let me just say it by. When it's inside the brackets, the minus means to the right. When it's outside the bracket, the minus means down. Okay, online, you got the graph? Clear? You got it? Yeah? So as I said, you're shifting it to the right 2 and down 5. Okay? So I just want to show you what this shift will look like. So the first shift to the right, it looks like this. Right? This point would have been 2. And your second shift, right? This is to the right 2. And this one will be down 5. This one will be down 5. So you're bringing the whole graph downwards, 1, 2, 3, 4, 5. So the graph might be somewhere here. Right? This point here is 2 minus 5. Right? The y-intercept might be wrong, but I'm not sure what it is. Right? But that's shift good enough then. You okay with that? Any questions online? Emily, any questions? Huh? What? Yes. All right. So from this now, we're going to the main one. This is the one that you will see in exam. All right. So I'm going to ask you a few shifts on this one, and we'll try to see what we get, right? Let's go with number 3. Suppose I ask you to shift. Let's not do too much, right? Let's do y is equal to 1 on x plus 1. What will that be? Of course, you have to watch it and identify what it means for the parent function is, right? So 1 on x means the parent function is this, right? And how are you going to shift it? Right. No, you're going to shift the whole graph 1 up. So you're shifting this, all these curves here, upwards 1, right? This asymptote stays the same, but this asymptote will go up 1. So that's the first thing I'm going to draw. I'm going to draw the new asymptote here. What's this equation? Right. Cutting it horizontal, so y is 1. Okay, you move it up 1, right? So the equation of this line is y is 1. The equation of vertical lines is x is whatever the point is. Okay, so y is 1 means you shift in the graph, you get the graph here, and you get the graph. Okay, always put you on 2. Yeah, always have a simple. That's really what's gonna x. Yeah, which I don't give you now. So you always have to have your simples. Okay, so the first shift here means 1 upwards, so I change the asymptote to y on 1. By the way, what's the name of this asymptote? Right. What equation is that? Huh? X is more than. What's the equation for this line? Y is 0.
Oh, yeah, why is it really?
What's the equation for this line?
Zero.
Okay. Yeah. Okay, that's the equation, y is 0. Right? That's the equation. If you remember, a horizontal line is always y is equal to something, and a vertical line is always x equal to something. Squeeze in one more here from us. Y is equal to 1 on x minus 3 plus 1. Right? Y is equal to 1 on 1 over x minus 3 plus 1. See if you can do that shift there for me. Kivish, what does this shift say again? The best one will go for it. Upwards, how much time? So, see, that's it. I move this line upwards 1. So I shift the whole graph 1. So what does this shift say now? Huh? Minus. You got it. You know it's right. Minus on the outside is up and down. Minus on the inside is what? So this is what? 3 to the right. Hurry up, do it fast. Get it already? But the asymptotes, right? So this is 1 upwards, this is 3 to the right. Put the asymptotes first and then sketch it. Ishmael, you okay? Ready? Clear? Clear. What will be the new? Well, we know this one already, right? We know here is y is equal to 1. Clear? What will be the new vertical arm? What will be the new vertical asymptote? The horizontal asymptote is this, right?
What's that line in the middle? Like?
Sure.
No. Yeah.
Yeah, clear. Anyway, huh? Yeah, clear. What will it be? X minus. What would the equation be? Minus 3 means it's moving where? Minus 3, it means it's moving to the right. Moving to the right 3. 1, 2, 3. So it's somewhere here. So that is x is equal to 3. Okay? That's okay? So the graph will be here and here. That's okay? Right. Samira, any questions? Kavisha, are you okay there? Amanda, all good? Just one more and we're done, right? Right. I have a big problem here. On the sketch list.
It's a big problem, right?
I want to sketch that. What is the parent equation for that?
One of our X.
Yeah, I will figure it out. Yeah. How to be? How to be that? How to be something with that?
Oh, if you have stretch, then we.
So what the value denominator? X minus 3. X minus 3.
What could you buy for that?
Y plus X. Huh? Anybody? Hey, John, any guess? None? Quadratic? Huh? You must pay the concept. So multiply by the conjugate of itself, you see that X squared. Anybody online, anything? Samira, any guess? I wouldn't give it something that could be wrong, right? There's a reason I give it up.
I don't know. I think in LY, I think X or I think on one of
Samira, any guess?
It will be like that, okay, as other.
All right, so you have an idea. So this year we are creating the form that we could actually work with, right? It's not looking like any other one here. But what is here? If I was a long divide, what I'm showing you here, right? So long divide, x into x is 1. 1 by x is 1 by minus 3 is minus minus. What you'll get here? 0 minus 2 plus 3 is 1. That's it. So you end up with 1 plus 1 over x minus 3. And that's the answer. And that's the answer. That's the remainder. But this is the remainder of what? Of this, right? Watch what? If you have 5 over 12, 5 into 12 is what? 2. Here you get 10. So it's what? 2 first, right? Right? Same thing here. Same thing here. Right? This is 1 plus 1 on x minus 3. And this is identical to what? Right? So you shift to the right 3, upwards 1. Okay?
Next way, it will go along the right.
That's it, long divided.
Use binary.
Alright, online. So now what this really is 1 plus 1 over x minus 3. Right? And this is the graph that we have here. Right? That's this graph here. You shift to the right 3, upwards 1. And it looks like that. Alright, that's number 5. Questions there?
You have next one?
Sure. Tell them I'll play to and we'll class you. I'll take off the next one.
I think we have to talk, but we have to.
Who?
Yeah.
So, well,
But it's only good for. Right, get upstairs. Downstairs. Anybody can come? Ah? No, no, it's gonna be next.
Christmas, whatever, I think like 2 months or something, I don't know. I think that my car goes out. Was that the Christmas? Alright, so nice. So that's that. Let's do one more for me now, please. What is seeing that? 3x plus 7 over x plus.
I get 1 over x plus 2.
Yeah. Yeah.
Alright, catch it quick and we're done. Right, so once you get sketch, we'll go into function. I know you all didn't do functions in advanced content, but it's a little more advanced than what you would have done in like
So when it's plus, it's that, right?
side bracket here.
Yeah. And now it's tiny bracket.
Huh?
Now we have like a tiny bracket.
Yeah.
Yeah, like that.
Finally, like the long divide, I kind of like.
Alright, so when you long divide, x plus 2 into 3x plus 7, x into 3x's, 3 by x's, 3 by 2. Minus 0, 1. So your answer is 3 plus 1 over x plus 2. Well, yeah, I didn't really do any examples with the number on top because it's hard to show here, right? But if you see a 4 on top, you just stretch it, but you can't see it, right? You can't see it because you don't have the original next there, right? So even if I put 4 here, you just, all you do is just say that vertical stretch. Yeah, they can bring it, but you can't really show it. So what does this shape look like, Shibish? 2 where? 2 where? Shibish, we just went through this boy. 2 to the left and 3 where? Huh? 3 up. Outside, yeah. Right downstairs, not straight, new one downstairs. So the graph is here and here. Right, the graph is here and here. All right. All right, online. So that's it for the first part of transformation.